Philo of Byzantium, also known as Philomechanicus, was a Greek engineer and writer on mechanics, who lived during the latter half of the 3rd century BC. Although he was from Byzantium, he lived most of his life in Alexandria, Egypt. He was probably younger than Ctesibius, though some place him a century earlier. Life and works. Philo was the author of a large work, Mechanic Syntaxis, which contained the following sections: Isagogia, an introduction to mathematics; Mochlika, on general mechanics; Limenopoeika, on harbor building; Belopoeika, on artillery; Pneumatica, on devices operated by air or water pressure; Automatopoeika, on mechanical toys and diversions; Paracelloastica, preparation for sieges; Poliorcetica, on siegecraft; Periepistolin, on secret letters. The military sections Belopoeika and Poliorcetica are extant in Greek, detailing missiles, the construction of fortresses, provisioning, attack and defense, as are fragments of Isagogia and Automatopoeika. Another portion of the work, on pneumatic engines, has been preserved in the form of a Latin translation made from an Arabic version. Further portions probably survive in a derivative form, incorporated into the works of Vitruvius and of Arabic authors. The Philo line, a geometric construction that can be used to double the cube, is attributed to Philo. A treatise conventionally titled De Septem Mundi Miraculis, on the 7 wonders of the world, is properly ascribed to another Philo of Byzantium, known as the Paradoxographer, who belongs to a much later date, probably the 4th–5th century AD. It is printed in R. Hircher's edition of Aelian. An English translation by John Blackwood is included as an appendix in The 7 Wonders of the World by Michael Ashley. Devices. According to recent research, a section of Philo's pneumatics which so far has been regarded as a later Arabic interpolation, includes the first description of a watermill in history, placing the invention of the watermill in the mid-3rd century BC, by the Greeks. Philin's works also contain the oldest known application of a chain drive in a repeating crossbow. 2 flat-linked chains were connected to a windlass, which by winding back and forth would automatically fire the machine's arrows until its magazine was empty. Philin also was the first to describe a gimbal. An 8-sided ink pot with an opening on each side could be turned so that any faces on top dip in a pen and ink it, yet the ink never runs out through the holes at the side. This was done by the suspension of the inkwell at the center, which was mounted on a series of concentric metal rings which remained stationary no matter which way the pot turns itself. In his pneumatics, Philin describes an escapement mechanism, the earliest known, as part of a washstand. A counterweighted spoon, supplied by a water tank, tips over in a basin when full, releasing a pumice in the process. Once the spoon has emptied, it is pulled up again by the counterweight, closing the door on the pumice by the tightening string. Remarkably, Philin's comment that its construction is similar to that of clocks indicates that such escapements mechanism were already integrated in ancient water clocks. Mathematics. In mathematics, Philo tackled the problem of doubling the cube. The doubling of the cube was necessitated by the following problem. Given a catapult, construct a second catapult that is capable of firing a projectile twice as heavy as the projectile of the first catapult. His solution was to find the point of intersection of a rectangular hyperbola and a circle, a solution that is similar to Heron's solution several centuries later.